In this example problem, we're going to make a regression equation to see how a bunch of different predictor variables related to a person's education can affect their starting salary once they graduate from college. We're going to do this in a two-step process. First, we're going to take the following three predictor variables, the student's GPA while in college, whether they had a management information systems concentration, or a major if you will, binary yes or no, and whether they minored in statistics, also binary yes or no. We're going to use that information to make our regression equation and make predictions about the four following scenarios, B through E here. All these students will graduate with a 3.5 GPA. We'll keep that consistent to isolate the other stuff. And then we're going to find the different combinations we can have of MIS concentrations and statistic minors. And then after we get done doing that in the top part, what we're going to do is we're going to make the same regression equation again, now adding an interaction variable. And there's the saying that sometimes the sum is greater than the whole of its parts. It's true in stats as well. Sometimes the interaction of two things in combination, having both of them, is better than having one or the other in isolation. There should be a bonus for having the combination of all things possible. Think about if you are training employees. You could have work experience, you could have proper training programs. Both of those would be really good for increasing the efficiency of your employees, but having both together is probably better than having one or the other substantially. So an interaction variable captures that little bit of extra. In this case, ours is going to be that little bit of extra, a major in management information systems and a minor in statistics, which should be the best possible scenario for preparing a recent college graduate in the field of business analytics to getting a high-paying job upon graduation. So let's get started. The first thing we're going to need to do is make our regression equation, taking into consideration their GPA in college, whether or not they had an MIS concentration, and whether or not they had a statistics minor. So just like I have done plenty of times in the last couple of videos, we're going back to the data analysis toolpack, and we want regression this time. And I'm going to hit OK. My Y range, the thing I'm predicting for, is what their salary is going to be upon graduation. So I'm going to grab the entirety of column B, their starting salary. And there should be 120 returns, so it takes you from B1 down to B121. And then my X's are the predictor variables that are going to help us determine what their starting salary should be. And it's the entirety of column C through E in this case. The entirety of the overall college GPA information we have, the MIS concentration information we have, and the statistics minor information that we have. And I throw all that in there. It should be C1 to E121. And I use the header, so I'm going to put labels in. And then lastly, I need my output range. And I'm going to put the output range on this tab instead of starting a new page. And I want that output range to be, if I can get this going, right here. I'll put it in cell H31. And I'm going to hit OK. And it's going to give me my summary output for this situation. So here I have all the information that I get to work with. Basically what we're saying is that someone who does not have any of these things and hypothetically has a 0.0 GPA, I know you can't graduate with a 0.0 GPA, but we'll just say hypothetically, would start at $44,000 a year. For each additional point they have in their graduating GPA, it increases their earnings by about $6,500. Majoring in management information systems, having that as your concentration, also increases about $6.5 million. And the stats minor, interestingly enough, seems to be more prolific for earnings in the business analyst field than the MIS concentration does. But we do have our equation. All it is up here in A, scrolling, zooming out a little bit so I can see everything, is just going to be equal to our intercept, our constant. What is going on with that? Try that one more time. And I don't know why I'm getting off track here. There it goes. It's going to be equal to our intercept plus our first coefficient, and we'll have x1 be our overall college GPA. Our second coefficient, we'll have x2 be the coefficient for our MIS concentration. And then lastly, we're going to have it be our third coefficient, which is for our statistics minor. So all things together, this should be our regression equation for making predictions. $44,000 a year to start with, plus the respective increases that we have for GPA, management information systems concentration, and our statistics minor. Now let's predict some salaries in lines B through E over here. The first thing we need is the predicted post-graduation salary for a graduate with a 3.5 GPA who did not have an MIS concentration nor a statistics minor. So all I need to do is just fill in this formula with x1, x2, and x3 being equal to the levels that we are testing for in scenario B, if you will, right here. So I'm going to say this is equal to our regression or our constant for our regression equation of 44.01 plus, in parentheses, the coefficient for GPA times the GPA we're testing for, which is 3.50, plus the coefficient for our MIS concentration, and in this case did not have an MIS concentration. Well, 1 is yes, which means 0 is no. So we're going to put a 0 in there, and then for the last pair that we have here, this is going to be equal to our coefficient for the stats minor times what we're testing for, and this is nor a statistics minor, so this should also be a 0. So all in all, our formula should be like that: 3.5 GPA with a 0 for each of the MIS concentration and the stats minor respectively. And I throw that into my formula, and I come up with 67.187. So this particular student in scenario B, once they graduate, their first post-graduation salary, they should start at a little over $67,000 a year. Let's move on down to C. The predicted post-graduation salary for a graduate with the same GPA, 3.5. We're going to keep that consistent so we can isolate out the effects of the MIS concentration and the stats minor. In C over here, they have the MIS concentration, but they did not get the stats minor. Well, I'm just going to fill in my formula. Our constant plus the coefficient for GPA times the GPA we're testing for, which is still 3.50, plus, in the second set of parentheses, the coefficient that we have for the MIS concentration, and in this scenario, C over here, they had an MIS concentration, so that would be 1, plus the coefficient for the stats minor, and in this one, did not have but did not have a minor in statistics, so that would be 0. And I throw all that information in, and I come up with 73.794. For D, one more time, filling in our regression equation, 44.01 plus the coefficient that we have for our GPA, which is still 3.50. And then our coefficient over here for whether there's an MIS concentration or not. For D, it's a 3.5 GPA and a stats minor, but did not have an MIS concentration. So that one would be 0. Close the parenthesis. Going on to another set, we're going to take the coefficient for the stats minor, and this student in D had a minor in statistics, so times 1, and that's going to come out to be 73.918, which kind of goes in line with what we had down here for our coefficients for our slopes. We said that a stats minor would lead to a higher starting salary than an MIS concentration, and right there, it's not much, but it is a couple $100, so it's going to be true. And then for E, we got both. A student with a 3.5 GPA who had the MIS concentration and minored in stats. So this is equal to 44.01 plus, in parentheses, the slope or the coefficient for our GPA. And we're still testing for 3.50, so let's multiply that by 3.50 plus the slope for our MIS concentration. And in E over here, they have both of them, so this will be a 1 because they do have the MIS concentration. And then in the last set of parentheses, we're going to add in the slope or the coefficient for our stats minor. They also are minor in stats, so that would also be a 1. And that comes out to be 80.525. So significant increase in earnings for having that particular setup than having one or the other. But are we underselling the importance of having both of them? Is that the best scenario? What if we have an interaction variable in this case that is going to give a little added bonus to someone who has both MIS and stats? Well, to do an interaction variable, all you do is you multiply 1 by the other. And it's really easy in this case because they're both binary. So unless it's 1 and 1, you're going to get a return of 0. So all I have to do in column F over here is multiply what I have in column D. So for graduate number 1, they would have the MIS concentration. Multiply that by, if they have the stats minor, there's a 0 there because they have no, and that comes out to be 0. And if I just go on and I fill this in down the whole thing, double clicking the fill handle in the corner, we got what we want. The only ones that return a 1 for this column is where they both have they have a 1 for both the MIS concentration and the statistics minor. So now with that new variable in, we one more time have to run our regression analysis. So I'm going to go back to the data analysis tool pack, open up regression, and I've got almost the same inputs that I had before, except my X range is going to change because now I don't want to stop on column E. I want it to be the entirety of columns C through F. I've got 4 predictor variables now, but everything else is going to stay the same. I still want to have a prediction for our starting salaries, my Y range. My labels are still on. For my summary output, I'm going to go and I'm going to throw that underneath the last table that we put in. So I'll put that right here in H52, and I'm going to hit OK. And there's all our information for this particular setup. So now, with that in there, we can definitely see how some things have changed between the two. The increase for the MIS concentration or the statistics minor alone, as we can see, has gone down significantly, like over $1,000 a year for both of these. But now what we're saying is that the having both of them is actually the thing that's going to increase your starting salary by about $3,500 because this is in thousands. As per the GPA, it's pretty close to what it was before. This model is giving a little more emphasis on how high your GPA was, but the real big jump that we're getting here with this interaction variable is that we're saying that the interaction between having both the management information systems concentration and the statistics minor is the thing that should really drive up your earnings in your first postgraduate job. So now I've got to go and make my regression equation again, and it's the same setup, but now we have a 4th variable, so we're going to have an x4 over there, but I'm still going to do the same thing that I did before. I'm going to grab my intercept as my constant. So round off, I'll come to 44.10. My coefficient that I've got for the overall GPA is 6.7109 rounded off. The intercept that I have for my X2, which in this case is my MIS concentration, is now fallen to 5.325 rounded off. For my 3rd coefficient, that's going to be the new coefficient that we have for the stats minor, 5.535. And then lastly, for our interaction variable, which is the MIS times statistics down here, 3.4915, if you will. And just like I did before, now that I have that information, I can just throw in the same things that we were working with above. It's the same 4 spots that we are testing for. So for our predicted salary under this model, for a student, this is a B, so a student that has a 3.5 GPA but didn't have either of these would be the 44.10 constant times in the first set of parentheses our slope for GPA, which is now 6.7109 times the GPA we're testing for, which, like it's been throughout this whole problem, is 3.50, plus the slope that we have for X2. And our X2 in this case is the MIS concentration. Well, for B, they don't have either of them. So from here on out in the formula, everything that we put in is going to be a 0, because with no MIS concentration, our binary variable return would be a 0. Here for the stats minor, the slope is now 5.5350, but in scenario B, they don't have it, so that would be a 0. And since they have to have both to get any credit, if you will, from this interaction variable of 3.4915, we're going to take that, we're going to multiply that by 0, and we come up with 67.588. So pretty close right here, but this model is putting a little more emphasis on having a high GPA than the last model did. For C, let's go back and keep going down the line. Just fill in your regression equation. 44.10 plus the slope for GPA times the GPA we're testing for, which is still 3.50, plus, in this case, the slope for the MIS concentration in C. The student has the MIS concentration but did not have a minor in statistics, so that would be a 1 here for the MIS concentration variable, plus the slope for statistics, and the student doesn't have a minor in statistics, so that would be a 0. And then lastly, the interaction variable slope of 3.4915 would also be a 0. Why? Because as you saw over here, you only get a 1 there if both of the numbers are 1. If there's a 0 for stats, this has to be a 0 as well. We can find a guy in here somewhere that looks just like it. Right here, there's a 1 for stats and then a 0, which makes the interaction variable 0. So with those inputs, that comes out to 72.913. So this model is having the earnings from just an MIS concentration lower than the original model. How about for the D scenario, if you will, 3.5 GPA, this one with the stats minor, but not the MIS concentration. Well, let's go and fill in our numbers. Take the slope for GPA, multiply it by the number that you are, the GPA you are testing for, 3.5. In this case, the student does not have an MIS concentration, just the stats minor, so we take the slope for the MIS concentration, multiply it by 0. Over here they do have the stats minor, so we'll take the slope for the stats minor, 5.5350, and multiply by 1 because they do have a stats minor. And then we'll take the slope in the last set of parentheses for the interaction variable, and since they had a 0 here, well, a 0 and then a 1 leads to a 0, because you got to have both to get the bonus from the interaction variable. Which means that our predicted salary in this particular regression equation is putting earnings of someone who has the stats minor but not the MIS concentration at 73.123 thousand, or 73,000 if you can change, if you will. So that is almost $1,000 lower than it was in our first model. And then for our last equation here, this is for someone who has both. So we take the 44.10 and add to it all the good stuff. Take the slope that we had for the GPA, multiply by our 3.50 GPA that we were testing for. Take the slope for having an MIS concentration, and since now they have both, that would be a 1. Add to that the slope for the stats minor times 1 because they have the stats minor as well. And then lastly, add to that the slope for our interaction variable. And for the first time, this is going to be a 1 because 1 and 1 gives you a 1. You only get a 1 for the interaction variable if you have both. In E, they have both. So that comes out to be 81.939, or 82,000 if you will, round it off. So what is the difference between these two models? Well, model B, if you will, the second one we did with the interaction variable involved, is saying in this case that the earnings of a student coming fresh out of college and joining the analytics field will be slightly lower than model A if they have one or the other of the MIS concentration or stats minor, will be higher by almost $1,500 if they have both. So this model is putting emphasis that the both of those things are the optimal qualifications that a graduate can have to get a good paying job in an entry-level analytics position. But how much of this is how much of what we're getting as a return is coming from the actual variables that are coming in? Is there something else in here that's dirtying up our return? Which one of these models is stronger? Well, to figure out which model is stronger, we got to find the adjusted R squared. We have more than one variable, so we have to use our adjusted R squared. So what is the adjusted R squared for our two different models? Well, all we got to do for each different model is find the adjusted R squared. The first time it was 0.790101, if you will. So I'm going to go and just fill in that number. But what was it for our second model? And our second model has an adjusted R square of 0.8028. So Not a huge difference. There's really not a huge difference in any of our numbers, but from this alone is our measure of goodness of fit. Our adjusted R squared for Model 2 is higher than Model 1, which means this should be a more accurate predictor of earnings. So all this put together is saying that there is more value in getting both of these qualifications than is represented if you just treat them separately. You need to account for the interaction, the positivity of having both of those things that will make you prepared to be an entry-level analyst entering the business field upon graduation.